Students, now we will learn various terms related to probability and methods of finding the probability. So let's start with the first, random experiments. Now see, an experiment in which all the possible results are known in advance but none of them can be predicted with certainty are called as random experiment. See, we know all the possible result in advance but we cannot be predicted for that result. Such experiments are called as random experiment. For example, see, tossing a coin. See, if you toss the coin, you will get head or tail. That means we know the result in advance but none of them can be predicted with certainty. Throwing a die. See, when you throw the die, you will get either 1, 2, 3, 4, 5, 6. That means we will know the possibility in advance but we cannot predict with certainty. So such experiments are called as random experiment. Now see, next we are going to learn outcomes, or it is also known as sample space. Now see, the results of random experiment are called as outcomes or sample space. That means see, the result of random experiment, if you toss the coin, you will get head and tail, head or tail. So these are the results. So these are outcomes or sample space, which is denoted by capital S. Now see student, next we are going to learn event. A set of outcomes which satisfy the particular conditions are known as event. There are different types of event. First type of event is certain event. The event which contains all the sample points of sample space is called as a certain event. Impossible event or null event. See, impossible, or it is also called as null event. An event which does not contains any sample points of a sample space is called as impossible event. See, that means if you throw a die, then there is possibility that you will get 1, 2, 3, 4, 5, 6. Right? So this will become sample space. But suppose there is event which does not contains any sample point, that means 1, 2, 3, 4, 5, 6, then that event is called as impossible event or null event. Now see the complement of an event. See, on complement of event, the set of all outcomes which are in S but not in an event is called as complement. See, the set of all outcomes which are in sample space but not in an event A is called as complement of event A. Now see, last one is mutually exclusive events, disjoint events. Disjoint, that means different. See, if A and B are the two events such that A intersection B is empty, null, then that means there is no common element in A and B, then they are called as mutually exclusive event. See, there are two events A and B, but there is no common element in A and B. See, for example, if you toss the die, in event A, you have odd number 1, 3, 5, and in event B, you have even number 2, 4, 6. See, A intersection B will become empty, that is no common element. Then these A and B are called as mutually exclusive event. Now see, last type of event is exhaustive event. If A and B are the two events such that A union B is a sample space, then they are called as exhaustive event. For example, say if in event A there are odd number 1, 3, 5, in event B there are even number 2, 4, 6. If you take A union B, you will get 1, 2, 3, 4, 5, 6. That is sample space. So these events are called as exhaustive events. Question number 1. In each of the following experiments, write the sample space. See student, first you have to write the sample space. Number of the sample points, that means N of S. Events, P, Q are using set. You have to write events P, Q are using and then number of P, number of Q, number of R. And find the events among the events defined above, which are the complementary events, mutually exclusive events and exhaustive event. See first, 3 coins are tossed simultaneously. P is the event of getting at least 2 heads. See, P is the event getting at least 2 heads. Next is Q is the event of getting no head, that means all are tail. R is the event of getting head on second coin. See student, 3 coins are tossed simultaneously. Now see, we will go sequentially. For example, this is coin. When you toss the coin, you will get either head or tail. Now 3 coins are tossed simultaneously. That means we have to consider like this. See, in stage 1, see, for the first coin you will have head and tail. So this is the first coin. For the second stage, stage number 2, you will have head, tail and head, tail. This is for second coin. And see, for the stage number 3, that is third coin, you will have head, tail, head, tail, head, tail and head, tail. Now we can write sample point. See, we can write sample point in sequence. See, stage number 1, stage number 2, stage number 3. So first there is possibility of H, 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 all the heads. Second will be H, H, T. Third will be H, T, H. Fourth will be H, T, T. Fifth, T, H, H. Sixth one, T, H, T. Seventh, T, T, H. Eighth, T, T, T. All the tails. That means sample point contains 8 numbers. So we can write N of S. So see student, we can write first, when 3 coins are tossed, S is equals to, see, these are the possibilities, H, 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 T, H, T, H, H, T, T, H, 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 T, 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 H, T, H, T and T, T, T. Number of S is equals to 8. Now see, P is the event of getting at least 2 head. That means you can take P. In P you can consider H, 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 T, H, T, H, H and H, H, T. See, we require at least 2 heads. That means N of P will be 4. Next, Q is the event of getting no head. See, no head. That means only tail is there and that is only one possibility, that is T, T, T. So, N of Q is equals to 1. And R is the event getting head on the second coin. See, on second coin there should be head. So, the possibilities will be, see, H, 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 second, that means middle will be head. T, H, 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 T and T, H, T. N of R will be 4. Now you have to find the events among the events which are complementary, mutually exclusive and exhaustive. Now see, we can observe student. Here P intersection Q is empty as well as Q intersection R is also empty. That means P and Q are mutually exclusive event as well as Q and R are also mutually exclusive events. See, because there is intersection, their intersection is empty, no common element. So we can write these are P and Q are mutually exclusive events, as well as Q and R are also mutually exclusive events. See exercise 4.1. Same question number 1. Now under that we will start with question number 2. See, same question is there. In each of the following experiments, write the sample space. You have to write the sample space, then number of S. Now P, Q are the events. You have to write number of P, number of Q and number of R. And you have to find whether it is complementary event, mutually exclusive event and exhaustive event. Now a die is thrown. P is the event of getting an odd number. Q is the event of getting an even number. And R is the event of getting a prime number. See, again the question carries 3 marks, student. Now see, student, when a die is thrown, so we can write sample space. See, die is thrown, that means we have 1, 2, 3, 4, 5, 6 numbers. So we can write the sample space 1, 2, 3, 4, 5, 6. So n of S is equal to 6. Now P is the event of getting odd number, that means 1, 3 and 5. So n of P, number of P is equals to 3. Q is the event of getting even number, that is 2, 4, 6. So n of Q is equals to 3. And R is the event of getting prime number. See, prime number 2, 3 and 5. So n of R is equals to 3. Now we can observe here P intersection Q is empty, no common element, therefore P and Q are mutually exclusive event. P union Q is equals to S, that means P and Q are exhaustive events. Also P and Q are complementary events. So they are mutually exclusive as well as exhaustive as well as complementary events. See, same question number 1. Under that we will start with question number 4. There are 3 red, 3 white and 3 green balls in a bag. One ball is drawn at a random from a bag. P is the event that ball is red. Q is the event that ball is not green. And R is the event that ball is red or white. Now see, student, question carries 3 marks. Now see 3 balls. See 3 red balls, R1, R2 and R3. Then 3 whites ball, W1, W2 and W3. And 3 green balls, G1, G2 and G3. So first we will write the sample space. Let 3 red balls, 3 white balls and 3 green balls be denoted by R1, R2, R3, W1, W2, W3 and G1, G2, G3. So if one ball is drawn randomly, S sample space will become R1, R2, R3, W1, W2, W3, G1, G2, G3. So n of S is equals to 9. Now P is the event that the ball is red, that means P is equals to R1, R2, R3. So n of P is equals to 3. Q is the event that ball is not green, that means it is red or white. So Q is equals to R1, R2, R3, W1, W2, W3. N of Q is equals to 6. And R is the event that ball is red or white. That means R1, R2, R3, W1, W2, W3. And N of R is equals to 6. Question number 1. Under that we will start with question number 5. See. From 2-digit number using digits 0, 1, 2, 3, 4, 5 without repeating the digits. P is the event that the number so form is even. See, we have to form 2-digit number by using 0, 1, 2, 3, 4, 5 without repeating the digit. Then Q is the event that number so form is divisible by 3, and R is the event that the number so form is greater than 50. Now first we will form 2-digit number. See, the 2-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5 without repeating the digits are, see, like this we can write digits 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So see the number. You will get first 10, 1, 0, 10, 1, 1, 11, 1, 2, 12, 1, 3, 13, 1, 4, 14 and 1, 5, 15. Then next second 2, 0, 20, 2, 1, 21, 2, 2, 22, 2, 3, 23, 2, 4, 24, 2, 5, 25. Then 3, 0, 30, 3, 1, 31, 3, 2, 32, 3, 3, 33, 3, 3, 3, 4, 34, 3, 5, 35. Then 4, 0, 40, 4, 1, 41, 4, 2, 42, 4, 3, 43, 4, 4, 44 and 4, 5, 45. Then next will be 5, 0, 50, 5, 7, 51, 5, 2, 52, 5, 3, 53, 5, 4, 54 and 5, 5, 55. Now see student, the number in that number without repeating the digit. That means we cannot consider this 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5. That means remaining numbers you have to consider. So we can write now the sample space. In that we are going to write the numbers 10, 12, 13, 14, 15, 20, 21, 23, 24, 25, 30, 31, 32, 34, 35, 40, 41, 42, 43, 45, 50, 51, 52, 53, 54. That is number of S is equals to 25. Now we are going to write the event. P is the event that number so form is even. See, even number 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52 and 54. So number of P is equals to 13. Next, Q is the event that number so form is divisible by 3. See, the numbers are divisible by 3, that are 12, 15, 21, 24, 30, 42, 45, 51 and 54. So number of Q is equals to N. And R is the event that number so form is greater than 50. Very simple. 51, 52, 53 and 54. So N of R is equals to 4. See, in the same question we will start with question number 6. A coin is tossed and die is thrown simultaneously. See, that means coin and die. Both you have to consider. P is the event that getting head and odd number. Q is the event getting either head or T and even number. And R is the event of getting a number on die greater than 7 and a tail. See, number on die greater than 7 and a tail. And the question carries 3 marks. See, a coin is tossed and die is thrown. See, a coin is tossed, that means possibility of head and tail, and die is thrown, that means possibility of number 1, 2, 3, 4, 5, 6. Now see, first we will write the sample space. See, the digits on the die are 1, 2, 3, 4, 5, 6 and toss, when you toss the coin, head or tail. So we have possibility of H1, H2, H3, H4, H5, H6. Similarly, if it is tail, T1, T2, T3, T4, T5 and T6. Hence we can write the sample space. H1 head and 1, head 2, H3, H4, H5, H6, T1, T2, T3, T4, T5 and T6. So number of sample space is equals to 12. Now P is the event of getting head and odd number. That means P contains H1, H3, H5. Number of P is equals to 3. Q is the event of getting either head or tail and even number. That means Q contains H2, H4, H6, T2, T4, T6 and N of Q is equals to 6. R is the event of getting a number greater than 7 and tail. See, on a dice there is no number greater than 7. Na? That means R is empty. So N of R is equals to 0. Now see student, we can observe here P intersection Q is empty. That means P and Q are mutually exclusive events. Q and R intersection is also empty. That means Q and R are also mutually exclusive events. In this way we can write the type of event. P intersection R is also empty. Therefore P and R also mutually exclusive events. See the next one, exercise 4.1. Same question, question number 1, in that question number 7. There are 3 men and 2 women. Gram Swachhata Abhiyan committee of 2 is to be formed. P is the event that the committee should contain at least 1 woman and Q is the event that committee should contain 1 man and 1 woman. R is the event that there is not woman in the committee. See, the same question carries 3 marks. Now see, let the 3 man be denoted by M1, M2, M3 and the women's denoted by W1, W2. A committee of 2 is formed in the following ways. So we can write first sample space M1, M2, M1, M3, M2, M3. See, like this we can write the sample space M1, M2, M1, M3, M1, W1, M1, W2, M2, M3, M2, W1, M2, W2, M3, W1, M3, W2, W1, W2. That means first we will write M1 with each of them. See, M1, M2, M1, M3, M1, W1, M1, W2. Then you will write M2 with each of M2, M3, M2, W1, M2, W2. Then we will write M3 with each M3, W1, M3, W2 and W1, W2 lastly. So number of sample points 10. Now P is the event that committee should contain at least 1 woman. That means P contains M1, W1, M1, W2, then M2, W1, M2, W2 and M3, W1, M3, W2 and W1, W2. So N of P is equals to 7. Q is the event that committee should contain 1 man and 1 woman. So very simple, M1, W1, M1, W2, M2, W1, M2, W2, M3, W1, M3, W2. That means N of Q is equals to 6. And R is the event there is no men in the committee. That means all are men. M1, M2, then M1, M3, M2, M3, number of R is equals to 3. Now we can observe here student, Q intersection R, empty. Because in R there is no woman, that means Q and R are mutually exclusive events. P intersection R is also empty. And see, we can observe here P union R gives sample space. That means P and R complementary events. as well as they are mutually exclusive events. Question number 1. In each of the following experiment, write the sample space. Number of the sample point in event A, B, C are there. You have to write number of A, number of B, number of C. Also find complementary event, mutually exclusive event. First, 2 coins are tossed. A is the event of getting at most one head. B is the event of getting both heads. C is the event of getting same face on both the coin. Now see student, 2 coins are tossed. So in this way we can toss coin, that means there is possibility of head or tail. So see, we can observe 2 coins are tossed. So for the first coin we have possibility head tail. For the second coin we have possibility head tail for the second coin. Now see, sample space contains H, T, TH and TT. So we can write the sample space H, T, TH, TT. So number of sample points is equals to 4. A is the event of getting at most one head. That means A contains H, T and TH. Number of A is equals to 3. B is the event getting both heads. Only one possibility, that is HH. So N of B is equals to 1. And C is the event of getting same face on both the coins, that is HH and TT. So N of C is equals to 2. Now we can observe here student, A intersection B is empty, but A union B is sample space. A intersection C not empty and A union C is sample space. That means A and B complementary mutually exclusive events, as well as A and C are exhaustive events. See, same question, problem set for question number 1. In that question number 2, a die is thrown. A is the event that prime number comes. B is the event that the number is divisible by 3. C is the event that the perfect square number comes up. See, when a die is thrown, we can write the sample space 1, 2, 3, 4, 5, 6. So number of sample points is equals to 6. A is the event that the prime number comes up. That means 2, 3 and 5. So number of A is equals to 3. B is the event that number divisible by 3 comes up. Only 2 numbers, that is 3 and 6. So number of B 2. C is the event that perfect square number comes up. Only 2 perfect squares are there, 1 and 4. So number of C is equals to 2. Now we can observe here student, B intersection C empty, no common element. B and C are mutually exclusive events. A intersection C is also empty, therefore A and C are also mutually exclusive events. See, next same question, problem set 4, question number 1. In that question number 3, a coin is tossed 3 times. See, A is the event that head appears once. B is the event that head at the most twice. C is the event that head does not appear. See, a coin is tossed like this 3 times. See, when the coin is tossed, possibility of head or tail. Now it is 3 times. Already we have sample space of this 3 coin toss in exercise 4.1. See, like this we can consider when first coin is tossed head or tail. For the second, head tail. And like this for the third. Now you can write the sample space H, T, HTH, HTT, THH, THT, TTH and TTT. A coin is tossed thrice, so sample space contains number of sample points will be 8. Now A is the event that head appears once. That means we can write HTT, THT and TTH. So number of A is equals to 3. B is the event that head appears at most twice. That means head will be 2 times. So B contains H, HT, HTH, T, HH, THT, TTH. Number of B is equals to 7. And C is the event that head does not appear. That means only one possibility, that is TTT. So number of C is equals to 1. Now we can observe here, student. A intersection C is empty. A and C are mutually exclusive events.